Good evening, Harry. I figured this would be easier rather than trying to type it in an email. Right, question 4. You need to find the possible values for x. And once again, we have a ladder. I would start with labeling this side y. Then, using the entire ladder, we have the equation x squared plus y squared is 10 squared or 100. Therefore, we can say that y is equal to the square root of 100 take x squared. Alright, now we put that one to one side for use later. Then I would use similar triangles. One triangle would be this, and the other would be this. Now, in an exam question, you'd be expected to establish similarity first. You do that by stating that this angle is shared. They have right angles there, therefore the third must be the same. They are similar because they have three identical angles. Right, now using the ratios. Taking the big triangle, we have x over y. The little green triangle would then give us x take 1 over 1. Now is where we use our Pythagoras from the first part, replacing y with square root of 100 take x squared rather, and that is equal to x take 1 over 1. Right, that has set us up with an equation that is only involving the term x, and we need to find x. Now, your calculator is very powerful. You could probably just plug that in to solve it and get the possible values for x. But let's say we wanted to do it a little more algebraically. We would cross multiply, giving us x is equal to x take 1, note the brackets are important, 100 take x squared. Now, essentially I want to get the square root term by itself, so I can square both sides and get rid of it. So I'm going to divide by x take 1, giving us x over x take 1 is equal to the square root of 100 take x squared. Now, square both sides. And remember, if you have a fraction and you square it, you're squaring both the top and the bottom. So here we have x squared over, please don't write x squared take 1 squared, because that's just painfully wrong. When you square this term, you get x squared take 2x plus 1, and that is all going to be equal to 100 take x squared. Alright. Now, a little more work to do before we're eventually going to put in our calculator. I would bring this entire term here up, giving us x squared equals 100 take x squared multiplied by, note the brackets again, x squared take 2x plus 1. Then I would bring the final x squared term over, giving us an ugly looking quartic. Now, if you wanted to at this stage, you could expand, simplify, write the quartic in general terms and put it in the polynomial function of your calculator. Or you can put it in graph mode. So, in graph mode, I've entered that exact equation that we've got, and now I'm going to ask it to graph. And you'll see, being a quartic, we have 4 possible roots, and it looks like all of them are real. G-solve root, negative. Now, clearly, going back to the question, x can't be negative. It's a length. So we discount it, move on to the next one. X is 0.9. Well, given the box length here is 1, I can't see how the ladder will go through the box to hit the wall. So we'll discount 0.9 also. In the exam, you'd be expected to list the answers and then discount the ones you didn't like and give reasons for it. Next, x 1.11. So it's a bit higher in the box, but I guess if the ladder was lying something like that, yeah, it could work. 1.11, we'll count that as an answer. And finally, our fourth root, 9.93, which is more like what the picture is stating. if that is our ladder. And there's your answer.